Equipment Lesson 9 covers fluoroscopic equipment and the imaging chain. Fluoroscopy delivers approximately 100 times more dose per minute than a standard radiograph. Understanding the equipment that produces the image, and its dose implications, is essential both for the ARRT registry and for safe practice. Every day, we cover the full fluoroscopic system, the image intensifier in detail, flat panel detectors, dose rates and FDA regulations, magnification modes, digital viewing systems, C-arm design, and image intensifier. Performance specifications. 14 minutes. For major components work together in every fluoroscopic system. The X-ray tube. Continuous or pulsed production during the procedure. High heat load, rotating anode with high heat capacity. Typical focal spot, 0.6 to 1.2 mm for fluoroscopy. The image receptor. Either an image intensifier, the older technology, or a flat panel detector, the current standard. It receives the attenuated beam exiting the patient and converts it to a visible image in real time. The video display chain. Monitor displaying the live image. Last image hold, digital subtraction, and road mapping. An automatic brightness control, ABC, adjusts technique automatically as patient thickness changes. Similar to AEC. In radiography, the FDA limit for standard mode is 88 milligrays per minute. Entrance air Kerma rate. Walk through the image intensifier diagram from top to bottom. At the top, the input phosphor, cesium iodide crystals. X-rays striking this layer produce visible light. Cesium iodide's columnar crystal structure limits lateral lights. Flat panel detectors have replaced image intensifiers in virtually all new fluoroscopic installations. Here is why. The detector uses amorphous silicon with a cesium iodide scintillator. X-rays produce light in the scintillator. That light hits a photodiode array beneath it, creating charge. A thin film transistor array reads the charge and digitizes it, producing a real-time image. Advantages over image intensifiers, DQE is 30 to 50% better, meaning less patient dose for equivalent image quality. No pincushion distortion. The flat geometry produces undistorted images. No veiling glare. No vignetting. Larger dynamic range. Smaller and lighter physical profile. An immediate digital output, directly to PCS. This chart shows why fluoroscopy demands special attention. A chest radiograph delivers approximately 0.1 milligrays for the entire exposure. Standard fluoroscopy delivers 1 to 10 milligrays per minute at the patient's skin. High-dose mode can reach 88 milligrays per minute, the FDA limit. 6 FDA requirements under 21 CFR Part 1020.32 govern fluoroscopic equipment. Standard mode limit, 88 milligrays per minute entrance air Kerma rate. This is the regulatory ceiling for continuous standard mode operation. High-level control, HLC, must require deliberate manual activation. Not the default mode. For procedures that clinically require higher dose rates. 5-minute audible timer, an alert sounds after 5 minutes of cumulative beam-on time, reminding the operator to document and consider dose management. Last image hold, LIH, required on all new fluoroscopic systems. Displays the last acquired frame after the beam is turned off, eliminating beam-on time for all review and planning activities. Cumulative dose display, the system must fluoroscopic. Magnification reduces the field of view to increase apparent image size. But it comes with a critical dose trade-off. In normal, full, mode, baseline dose rate. Full detector. Area utilized. At 1.5 times magnification, approximately 2.25 times the baseline dose rate. At 2 times magnification, approximately 4 times the baseline dose rate. At 3 times magnification, approximately 9 times the baseline dose rate. The rule, dose rate increases by the square of the magnification factor. 2 times magnification means 2 squared equals 4 times the dose. 3 times magnification means 9 times the dose. Use magnification only when clinical detail specifically requires it. Return to normal mode the moment the detail work is complete. The dose impact compounds quickly, particularly in long interventional procedures. For digital capabilities extend what fluoroscopy can do beyond real-time imaging. Spot image acquisition, still images captured at higher dose. Then continuous fluoroscopy. Documented in the medical record. Digital spot images. Acquired directly from the flat panel detector. Cine fluoroscopy. Records rapid image sequences, 6 to 60 frames per second. Used in cardiac catheterization, angiography, and barium swallow studies. High dose. Per procedure, frame count times dose per frame. Digital subtraction angiography, DSA, a mask image. Acquired before contrast injection is digitally subtracted from the contrast image. Only vessels remain visible. Requires patient stillness, any motion causes subtraction artifact. Road mapping, a prior contrast image overlaid on live fluoroscopy to guide. Catheter placement. Reduces live beam-on time by allowing the operator to follow the map. Must be updated if patient or C-arm position changes. The C-arm gets its name from the C-shaped gantry that allows the tube and detector to orbit around the patient. Tube position. 3 image intensifier performance specifications. The registry tests. Flux gain, the energy amplification produced by accelerating electrons through the high voltage. Typically 50 to 100 times. Electrons arrive at the output phosphor with significantly more energy than they left the photocathode with. Minification gain, the amplification from compressing the large input image to the small output image. Calculated as input diameter squared divided by output diameter squared. For a 23 cm input and 2.5 cm output, that is 23 squared divided by 2.5 squared, approximately 84 times. Total brightness gain, flux gain times minification gain. Typical values, 1000 to 6000 times. The bar chart on this slide shows the components, approximately 50 times. Flux gain, approximately 80 times minification gain, and a total of approximately 4000 times. The conversion factor, GX, is the current standardized measure of image intensifier efficiency. It replaces the older brightness gain measurement. Output 3 fluoroscopy. Equipment questions. These are clinical scenarios, think before the answer appears. The answer is C. The dose rate increases approximately 4 times. In fluoroscopic magnification mode, dose rate increases by the square of the magnification factor. At 2 times magnification, 2 squared equals 4 times the dose rate. The system needs more radiation to maintain image brightness across the smaller active detector area. Use magnification only when the clinical detail requires it, and return to normal mode immediately after. The answer is B, last image hold. LIH displays the final acquired frame on the monitor after the beam is turned off. This allows the operator to review anatomy, plan the next step, and take measurements without activating the X-ray beam. Studies show consistent LIH use reduces total fluoroscopy time by 30 to 50%. It is required on all new fluoroscopic units by FDA regulation and is the single most dose-reducing feature available to the operator. The answer is C, elimination of pincushion distortion and veiling glare. Flat panel detectors use a flat geometry. No pincushion distortion. No internal tube scatter, no veiling glare. Superior DQE means 30 to 50% lower patient dose for equivalent image quality. No vignetting. Larger dynamic range. The main disadvantage, higher initial cost. You covered the fluoroscopic system components, the image intensifier diagram with all 5 layers, flat panel detector construction and advantages, dose rate comparisons and FDA regulations. Magnification mode dose relationships, digital viewing modes. Including DSA and road mapping, C-arm geometry and radiation. Protection requirements, and image intensifier brightness. Gain calculations. Fluoroscopy equipment is tested heavily on the ARRT.